Welcome to Work Holding Techniques for Multi-Axis Machining by Todd Frazee of Sierra College. Precision and stability are critical to achieving high-quality results in multi-axis CNC machining. Self-centering vices using dovetail fixtures are work-holding devices commonly used in the industry. This lesson explores how these two tooling elements enhance efficiency, accuracy, and flexibility in multi-axis CNC operations while minimizing material waste and optimizing toolpath. The objectives of this lesson is that by the end of this lesson, you will be able to understand the role of self-centering vices and dovetail fixtures in CNC machining, identify the benefits of self-centering vices in the workpiece positioning, identify the advantages of profiles in work holding, model CAM and 5-axis CNC milling applications to industry standards, and apply CAM and 5-axis CNC milling applications to industry standards. Dovetail profiles. They shown on the right is a piece of aluminum with a dovetail feature machined into it. From the end of the profile itself somewhat represents the tail of a bird, so that's why it has the term dovetail, probably borrowed from the woodworking industry. The dovetail profile requires machined material preparation. So when you're planning your job, you have to think about this pre-operation or material prep really as another operation and so of your manufacturing process. So if you're looking to move a two-axis or three-axis part to 5-axis technology and it's only two operations, you may have pause because you first have to machine the blank to give the profile to grip onto, and then after it comes off the 5-axis machine, that dovetail has to be machined off. So it's adding two operations to whatever operations are done on the 5-axis. So you want to gain that your total net number of operations is reduced by implementing 4 or 5-axis manufacturing processes. Okay, the dovetail angle and specification vary by manufacturer. Some devices incorporate a pin to locate the material blank and to prevent the blank from being misloaded. But again, that's another feature that has to be machined in order to prepare the material to start work. The advantages of the systems are it's a very strong gripping force on a minimal contact surface. And the grip profiles can be as thin as 80 thousandths. I've seen anywhere between 1/8 inch and 80 thousandths, depending on the system. And the primary advantage of it is it allows free access to all sides of the part except for what's being held onto in a very small surface area, and allows you to do machining without having to avoid clamps and other types of bulky fixtures. Now, self-centering vices, they've become very popular in 5-axis work, primarily because they can hold workpieces of varying widths without moving the center line. So you could clamp 2 different width blocks, and your origin, if it's centered on the vise, will remain centered on the vise. Okay, so it accommodates a variety of stock sizes without shifting your work coordinate system, or WCS. This reduces setup time and also reduces the amount of misload errors because the clamping technique is the same over across section of parts. So the operator doesn't have multiple training opportunities where they could misload a part. And it reduces the need to fabricate and inventory custom fixtures. So that becomes a problem for a manufacturing operation where you have a whole inventory of fixtures and the setup and maintenance related to that. Now let's look at some of the brands of, this is just 3 survey brands of different work holding systems that use the technology we're talking about in this lecture. A Raptor is a system that we early adopted at Sierra College, and they do make self-centering vices. The taper angle on their work holding system is 60 degrees for material preparation. The advantage of the 60-degree angle is it puts a significant amount of downforce on the part, but the downside is you have a taller profile than some of the other systems. So you have to have a thicker amount of material devoted to holding the part. They start out with these fixture blocks, and again they have the little locating pin. The one reason we're moving away from this at Sierra College is the requirements tolerance wise for their blanks is very high for both the height of the dovetail and the location of that center notch that corresponds with the locating button. If we have to put a lot of precise care into the blanks, then it kind of defeats the purpose in some ways of having a quick preparatory operation. And then they also make 5-axis pyramid bases. This one holds 3 fixtures and tombstone fixtures, which allows you to do multiple part loads on your 4 and 5-axis equipment. The tombstone type is typically on a 4th axis, whether that be a vertical mill with an A or B axis rotary, or on a horizontal mill with a B rotation. Okay, fifth axis brand. It's quite apropos that they just call their company Fifth Axis. They make self-centering vices. The dovetail profile in their system is 45 degrees. And they also make fixture blocks similar to the Raptor system. Looks like they incorporate a locating button in a different location. And they do make 5-axis pyramid bases that those can go on. And they feature a quick change tooling knob system, so you can quickly remove this from a subplate and slap on another one of their systems, and they repeat within a few tenths. So that's an advantage of that system. So their tombstones are quite a bit more simple. They just have the locating features for the knobs and then a mechanism to tighten it and lock it in place on the tombstone. Technigrip is another system. It's been around for a while that I've worked with at Schilling Robotics. And it also uses a 60-degree profile, but its clamping mechanism is different. It's modular. The idea is the fixture can be reconfigured for different jobs. This is an example of one of their fixtures for a 5-axis machine. But their primary bread and butter products, this modular fixture system. And as you can look at the end of this, you can see that there's the clamps in this can be moved around to different locations. And then on top, they have locating buttons that can be exposed by unscrewing them or screw them down and they're flush. Again, it incorporates a 60-degree dovetail, which puts more down pressure, but you have to have an 1/8" minimum dovetail profile to hold on to their system. And the configurable clamp and pin location systems are alphanumerically labeled, with the alpha being, or letter being, the clamp location on the fixture and the number being the pin location. So in your work instructions, you can tell the setup operator that you need a certain configuration. So in this example, the documentation would say put a clamp in location B and E and raise location buttons in either locations 2, 3, or 4, and then that corresponding slot would be machined into the prep of the block, and it not only locates the block in the opposite axis as the dovetail, but it also acts as a load protection. If you load the wrong blanks for the wrong job in the fixture, it just won't load because the pin configuration won't match. So here's an example of a longer fixture with a part on it. They've got a clamp in location D, F, I, and L, and then somewhere there's at least 1 or 2 location buttons that are raised up that are hidden by the part, so that only that blank can go in that specific location. And they also make tombstone fixtures, similar configuration. Typically you need a minimum of 2 clamps, and then the location buttons or pins are already in the system. All right, so in summary, the precision and stability are critical to achieving high quality results in multi-axis CNC machining. Self-centering vices using dovetail fixtures provide this, and they're work holding vices commonly used in the 4 and 5 axis industry. Self-centering vices automatically adjust to hold the workpieces around a center point, which reduces the setup time and improves accuracy, and especially for complex geometries. And the dovetail profiles provide a strong grip with a minimal surface contact, which is ideal for high precision machining and maximizing access to the workpiece. In conclusion, by the end of this lesson, you were able to understand the role of self-centering vices and dovetail fixtures in CNC machining, identify the benefits of self-centering vices in the workpiece positioning, identify the advantages of dovetail profiles in work holding, model CAM in 5-axis CNC mill applications to industry standards, which you'll be doing in your assignments, and apply CAM in 5-axis mill applications to industry standards, which you'll be applying that CAM to machined parts you make in the lab, which will be held onto by a dovetail type vice system. Thanks a lot, and we'll see you on the next lecture.